What's up, guys? How's it going? You have the privilege of learning about Theorem 7.3 and 7.4 right now. We're going to start with 7.3. Here it is. It's the parallelogram opposite sides theorem. Say that 10 times fast. Good luck. It says that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So by definition, a parallelogram, if we look at these two opposite sides, this guy and this guy, and if we remember, this is the notation, these two lines on either side say that these two sides are congruent or the same. And again, these opposite sides with the one dash mark are also congruent. So both sets of opposite sides, if it truly is a parallelogram, must be congruent. Okay, that's all Theorem 7.3 is saying. Now let's scroll over, if I can find my scrolling knob. Scroll. Theorem 7.4 says that if the quadrilateral is a parallelogram, then its opposite angles are congruent. So the same idea, but now we're talking about angles. So this angle here, angle A, must be equal to this angle here, angle A, and vice versa with our other angles. Angle B must be equal, congruent to the opposite angle B if it is truly a parallelogram. So that's essentially the definition of a parallelogram. If we have a parallelogram, if we know for sure, if somebody states this is a parallelogram, we can say for sure that the opposite sides are equal. So this side, we can put our two dashes, must be equal to this side, and this side here must be equal to this side. And in addition, Theorem 7.4 says the opposite angles are equal. So this angle B is the same as this angle B. This angle A is the same as this angle A. So that is Theorem 7.3 and 7.4. Let's do a quick problem. Let's see what you guys are going to be asked to do. Something like this. So, very important. Let's circle this in yellow because it's very important. It says this shape is a parallelogram. It must be a parallelogram for us to use either Theorem 7.3 or 7.4. So now that we've said for sure that it is a parallelogram, we can begin to solve. And of course, it's asking us here to solve for the unknowns for the variables g and h in this case. So all we need to know is what are the relationships we have. So Theorem 7.4 tells us that our opposite angles, so in this case our b's are equal, right? Our opposite angles are equal. So these two angles, 65 degrees on this side, and on this side, g plus 4 degrees, must be equal. So let me change my pen color to something nice. Let's go green. So g plus 4 must be equal, must be congruent to 65. So now we've got our nice basic algebra. Subtract 4 from either side. Getting better at writing with the mouse. It's kind of difficult. So g must be equal to 61. So there's g, and then same thing with our opposite sides. Our opposite sides must be congruent. So change color again. Let's go purple. Very fancy. So 7 this side, 7 must be equal to this side because of Theorem 7.3. So 7 must be equal to 16 minus h. I'll work on my computer handwriting still, it's not the prettiest. And again, simple algebra, subtract 16 from both sides. Let's see if I can give myself some more room here. And we are left with, let's see, oh, we got one more step. So we got negative 9 equals negative h. And divide both sides by our negative 1, or essentially just cross off our negative signs on either side. So cross that away and cross that away. So h is equal to 9. So hopefully that made a lot of sense, right? We can use both Theorem 7.3 and 7.4 to say some pretty powerful things about what a parallelogram, what's congruent in a parallelogram in terms of angles and sides, and we can solve for unknowns. Thanks for watching. The code word is, let's find a cool sticker. Just to prove that you watched this, you are going to need to come to class and tell me how did I make this thing? What that is. What is the thing that I placed on the screen at the end of the video. Dun dun dun. What is that thing? Have a great evening.